All right. So today we learn about tidy data. We are specifically going to talk about one package, two packages actually, which go hand in hand. Uh, One is called tidyr, and the other one is called dplyr. So these two are some of the packages which we heavily use every single day. The last class we had, we talked about ggplots2. So ggplots2 and for plotting, and these two packages for cleaning up the data set is what we use pretty much every single day. So I thought this would be important to go through, because this has some of the very cool functions that you could use, and that could be helpful, and that could make some of the complicated tidying of the data and formatting your data much easier. So it's this tidy data, tidyr and dplyr are all written, and ggplots as well as ggplots and ggplots2 are all written by a person named Hadley Wickham, and he is the author of RStudio, and also he has written all these packages. So, and he's the person who maintains and these packages as well as RStudio. So I think he has a team. I don't know much, but I think he's in Texas. But he maintains these packages, all of these packages, as well as RStudio releases. So, and most of what we are going to do today are picked from his website, and all these links I've shared over here. So he has a blog on our blog, r-bloggers.com. I think I shared with you this website in one of the first sessions. So he maintains this blog, and so he has some posts on tidyr, plyr, and dplyr. So these three are very useful for formatting your data before even you start analyzing your data. And the actual paper for this tidyr is over here, but the second one is more like he has these little code snippets in this paper. And I have included another link over here just as a cheat sheet for ggplot2 that we covered last week. So talking about data tidying, it's often said that it's 80% of the work, because any data set that you deal with, any data set that you get, it's highly unlikely that you will get it in a format that is ready for plotting or ready for analysis. It's highly unlikely. So you'll often have to clean up your data set and spend 80% of your time cleaning and preparing your data and formatting your data for just 1 second. So most of your time you have to spend preparing and cleaning up your data. So your data preparation step is not just the initial step, but you'll have to repeat this step over and over in your course of analysis, because as you go through, you will see that if you pick up one data set and start working on that data set, initially you'll have to do some part of the formatting and cleaning. But as and when you start plotting individual bits of these data sets, you will have to format it in a way that is suitable for ggplots, and most likely if you're using ggplots. But if you're even plotting it for your using the normal plotting mechanism in R, you'll have to format it in a way, or you'll have to convert it into data frames or matrices or any other structures. And for ggplots2 or ggplots, you'll have to have like a long linear version of it, because you'll have to make it not like a table with many columns, but you'll have to make it into a linear version and long version where you'll have one observation, one variable, and one observation in each row. So ggplots2 works that way, where if once you have your data in that form, you can easily plot those. So much of the challenge in preparing this data set and formatting this data set will depend on your individual data sets. And that's why there is no hard and fast rule as to how to clean your data. And there is nothing set in stone that you have to go through your data, follow all these particular steps before you start analyzing, because every data set is different. And what we do generally in microarray analysis or sequencing and in the biological field is we do outlier checking. We do data. If there are dates in your data, we do parsing of that dates and convert it into a numerical format. And if there is any missing value, you'll have to know how to deal with it. Any missing values, if you want to convert all the missing values to, say, a very low value in your data, you could do that. And after all of these, then we start doing technical association of the variables if they are associated to any of the impending factors, like confounding factors like the date, the quality, the batches, and etc. And what we do is we adjust the data to those variables. So all this is a part of pre-processing or formatting your data before you start your analysis. And depending on what data set you have, these steps will vary. So there are a few principles for how your data should be organized, at least for using tidyr package. And these standards are, again, these are just very brief standards. So your data set might fall into this or not, depending on what data set you have. And so we will just go through a few steps which tidyr package uses. So this is just a quote from Leo Tolstoy, who says, "Happy families are all alike, but unhappy families are unhappy in its own way." So they applying this to data sets, it's like a messy data set is each messy data set is messy in its own way. But if it's tidy, there are certain qualities and certain standards that all the tidy data set follows. So there are three rules basically. One is you will have to have every variable in a different column, and you'll have to have one observation per each row. And if you have different forms or different units of observation, they have to be in different tables, not just crammed into one table. So we'll just look at one example of how a messy data set looks like and what you can do to linearize it or put it in a format that is easily used for plotting and further analysis. So here I have some more rules. It's not really rules, but some problems that you may encounter with messy data sets and how you can change these. So mostly column headers have to be there. They are not values, but they are variable names. So you will have to have your column names set and make sure that multiple variables are not stored in one column. So if you see that certain values are comma separated or delimiter separated and put in one column, you'll have to parse them out and put it in different columns. And variables should be stored so one of the other quality of messy data sets is variables are stored both in rows and columns. So we don't want that. So some of these variables may be stored both in rows and columns, and I'll show you one example of that, and where you'll have to linearize them, and you can do that easily using this tidyr package. And the other problem, the other problem may be multiple types of observational units are stored in the same table. So sometimes it's easier to separate these observations into different tables and then merge it on the fly when you're actually doing the analysis. That keeps the data, these tables separate, so we don't merge the information. So usually one example of this is if we have patient-related clinical parameters, we put them separate, and the actual experimental data will be separate. And when we are doing the analysis, we merge these two tables. So we put them in two separate tables, but use the information as and when we need them. And the other problem may be a single observational unit is stored in multiple tables. So some of these concepts are borrowed from databases. If you are familiar with databases or relational databases, some of these concepts look alike, where relational databases emphasize the need for normality in the data, which is each row has to have its own observation, and each column should have a different variable. So I'll show you more examples of these, and we'll have within tidyr there are some tools like for gathering, separating, and spreading the data. So we'll see that, and we'll practice some of those. So the way you install tidyr is similar to all the other packages that you installed. Install.packages, and you put tidyr, and there are some dependencies, and those also will be installed. And after tidyr installation, you can load. So both, I think, are packaged in the same package right now, tidyr. So you can load the library tidyr as well as dplyr. And we'll see some of the examples that came out of the author's blog. So before going into examples, I would like to you to take a look at this function in R, which is a piping function. If you're familiar with Linux programming or Unix programming, there is a pipe function which will look like just a line in the command. So you pipe the output of one command into another command, and so on and so forth. So similar way, R also has a pipe command, pipe function, and what it does is it's just a symbol, which is this symbol here that you see. There is a percent and then a greater than sign, and then another percent symbol. So this is the symbol of pipe, and what this will do is it will help you to pipe or take the output of one command and put it in another command. So one example here of the utility of the pipe function is, when do you use pipe function is if you don't want to store the output of every single function, such as this example over here. I have some filtered data. I'm using some functions, creating a subset of the data set, storing it in this variable, and then using this variable for another function, and then creating another data set, and then using this data set to create something else. So if you're doing a series of functions where you don't really need to store the intermediate data sets that are formed, then you could use the pipe function. And the pipe function is very simple, where you have to first use the data set name. Here we are using the air quality data set, we're using the pipe function, and then running a series of functions and piping it to the next function. So this way you don't have to really store the individual data sets that comes out of every step of these functions. So filter creates a data set, and so here the meaning is air quality is the data set that's piped to this function. So you really don't have to give it another data because it's already piped. And then filter, use the filter function, and which creates another data set, a subset, and that is piped to the next function, which is group by, and then that's piped to the next function, which is summarize. So these individual functions, filter, group by, I've not gone through in the previous classes. I'll go through in this class towards the end of the session. So let's go into the example, one of the example of a messy data set. So here we are creating a data frame, and we have a bunch of names, and then we have two variables. One is A and B, and these are likely drug and heart rate. I'll tell you in the next slide. And these are some of the values. So if you look at these, one column forms the names, one column forms the variable A and the variable B. This is typically the same that we used in many other previous sessions, but now I'm saying that this is a messy data set. It is because if you start using it in ggplots, you would likely want each value an individual variable as one line or one row, and not, because if you see this row, you have the name and you have two values or two observations. But likely the long slender format of the data will likely have just the variable name and one value instead of these two variables over here. So let's look at that. So there's one function called gather within tidyr. What it does is it creates the long slender format of one variable or one observation per row. So what you do is, what it takes is, it takes the data set, because the data set is piped, you don't have to give it over here, but if you're just using gather by itself, you'll have to say gather and then give it the data set messy as the first argument. And then you give it the names of the new columns that you want. So you give it the names of the new columns, and then the third argument is going to be how you want to treat, or how you want to duplicate and make this long slender data set. So if you remember, so if you look at the actual data set, there's A and B columns, and then you'll have a few numbers for each of this. So what you're saying gather to do here is, you're saying for every A, duplicate all the, not duplicate, for A, and you use A and B as the keys. So what gather does is it will take all the column names that you give it in the arguments, it will take those and put it in key value pairs. So what is the meaning of key value pairs? So you have a variable name, and then you have its value. So if you look at A and B here, what it does is drug, it adds this new column drug and the new column heart rate, and then it because the actual name of the variable is A, right? So it puts A over here, and then it puts the values of the within the A column as individual rows. Then it duplicates the names. So the names are duplicated. The three names are here, and then the three names are added to the bottom of this, and then the variables, everything are in a linear format now. So this is a format that is needed by ggplots, because you could directly give it you remember the tilde sign, and then you could directly give it the facet or the facet grid, depending on how you want the plots to look like. So you could use the tilde sign. You could put on the right hand side of the tilde, you could give it the drug. So it's going to divide based on what you want. Like if you say if you want box plots, it's going to divide this drug column into two boxes, one for A and one for B. So if that's what you want. So this format is a universally acceptable and a good format for plotting, which has like one value or one observation per row. So before going into the next example, any questions? Okay. So let's just try this out and see. And I have the two, I have to load the two libraries. Okay, so this is the air filter data. No, let me skip this. This is just to emphasize the need for the pipe symbol and the piping, but we'll come back to this a little later. We'll first run the Massey data set. So create the Massey data set. It's going to look like this, and this is the gather is going to put them in a long linear long format like this. So this is the help documentation page for gather. So it puts the data into key value pairs. The first argument is going to be the data set, but since we used piping here, the data set is automatically going to be piped into the function. And you have certain examples over here. You can try those, and I'll show you the meaning of this negative symbol in the next example. All right, so sometimes the variables are in one column. So you may use another function, which is also a part of tidyr, called separate, to separate the variables. So the data set that you have here is just how much time people spend on their phones at two locations, work and home, at two times. So they are randomly assigned to two groups. One is treatment and control group, and you have the times at two locations, work T1, home T1, and the second time measurement, work T2 and home T2. So this is a messy data set because you have 4 observations in each row. I know in the past we have dealt with the data as it is like this. But as and when you will discover that as and when you keep going into more complicated analysis, this format is not that helpful. If you want to, and specifically if you want to use ggplots. So ggplots is something that that is more popular now instead of the conventional plotting mechanism in R. So ggplots does not like this format. So here we have 4 observations per row, and we'll have to tease apart these observations. And also we could use gather to do that, to use to generate key value pairs. But then this is work.t1. If you want all the T1s also in a separate column, then we'll have to use the separate to separate those. So the first step is to use gather, and you'll have to use, you'll have to give the 2 new column names, which is key and time. and you're giving a negative symbol to this ID and treat. So if you're saying negative symbols, if you're giving it negative symbols, it means that do not consider those columns in your key value pairs. So to whatever column or the variable name you give this negative sign, what it does is it simply duplicates those to how many ever key value pairs gather generates. So here, if you look at the output of this, it's just duplicating those ID, which is 1 to 4 IDs, and the treat, which is treatment control, and it will duplicate this information, the first 4 lines of information, over and over until your key value pair ends. So that's how it's going to do. And what it's doing for the key and time, it's going to take all the 4 columns after ID and treat. It's going to take all these 4 columns and put it in a nice long linear format. So what it's going to do is going to put work.t1 and the first value in one row, work.t1 and the second value in the next row, work.t1 and third value in the next row. It's going to be a long format. So that's what it's going to do. Put all these values in a linear format, and then home.t1 all the 4 values. Now, if you want to separate the T1, because this key the key values are all clumped together, which is work and then T1. So this will not let you analyze if you want to combine all the works together, which is work.t1 and work.t2. This will not allow you to do that. So you'll have to separate whatever comes after the dot into a different column, so you have more flexibility with your data. So that's what separate does. So you can pipe the previous one and separate the particular column that you want to separate. So here you give it the column that you want to separate, which is the key over here, and then you give it the second argument, which is the into, and give it 2 new names, because you are splitting the key values. You're splitting it into 2 columns called location and time, and then you will have to give it by what you need to split. Always the splitter may not be a dot. It may be anything. It may be a colon, it may be a semicolon, it could be a comma or anything. So you'll have to give it the separator, and you cannot directly give a dot because a dot in our terms means it's the current directory. So you'll have to escape the dot by giving these 2 backslashes, and then it will consider a dot as a symbol and not the current directory. So you'll have to give it the separator, which is the dot, and then the output is going to separate work and time. So all the times will go into one column and the location will go into another column. So now you have more flexibility with the data. You can see the differences or the box plots between, various times or various locations and things like that. Yeah, so before going into this, let's just see it practically. So this is my data set. So you have work.t1, home, t1, work t2, home t2. So now, messy, you're taking that data set, you're using the piping symbol, you're using gather and giving it the new names for the columns, key and time, and you're saying negative ID and negative treat, which means don't take those 2 columns into key value pair consideration. Just leave them alone and duplicate them as many times as the key value forms. So you can assign all of this also into another variable, and you're calling it tidyr. So if you run this, and tidyr is essentially going to be a long file. Basically, these 4 rows are going to become 16 rows because it's separating all of these variables. So here I'm just piping it to head, so you could do that too. Usually head displays only the top 6 rows, so you could pipe it to head and you can call how many ever rows you want it to display. And then you want to separate this column, which is the home.t1, into 2 separate columns. So you give it the key, the name of the variable to separate, and then how many new columns you're going to separate it into, and then you give it the separator. Oh, I think it's not right because so now it's separate. So so the earlier I had closed this round bracket over here, which is not right because into, you'll have to close it there because into should have the new column names now. So you'll have to close the brackets over there, and then separator, the separator is a argument of separate, not into. So you have this, and it's now neatly formatted, and now you can use ggplots on this, and you could give it time versus location or time versus time. So it's two the same names. Are actually, I should maybe call this as this, so we have a different name for both. So now you could use one of this, and you could use this value, the time value, and you could give on the right hand side of the tilde sign, you could give it location or the time, and based on that it will separate the data. In aesthetics you could give the x values and y values, and based on that it separates the data on its own. All right, so let's go into the next part, which is the dplyr. It's not dy, it's dplyr, and this is a package for data manipulation and written and managed by the same person. So I have one link over here which shows some of the functions that I'm showing over here, picked up from this link. So for this, we'll be using the air quality data set. I think you have seen this previously. It has measurements of ozone, solar radiation, wind, temperature, and month and day. So in the beginning of the class, we saw the function called filter. So filter is an easy to use function. It does what the name says. It will return a subset of the rows satisfying the condition you would give it. So here what we are using filter for is to filter the air quality data set for temperature greater than 70 degrees. So whatever condition you give it here, that will be applied to the data set. That's the first argument. And then the subset of the data set will be displayed. So so that's the very first one over here. So that's the result. It's just going to display a subset, which is greater than 70 degrees temperature. So the other one you could use in this sign is month, or anything equal to certain number. So in R, if you remember, we cannot give a single equal to sign. A single equal to sign doesn't mean, it means assignment. It's not comparing. So you'll have to give it a double equal to symbol. So if you want to filter the data set for the 5th month, then you'll have to give it a double equal to symbol, and then you see this data set, which is filtered for just the month of May. And you could use this symbol and to use 2 conditions, or you could use even more than 2 conditions. You could give it a string of ands and use more than 2 conditions. So if you want to filter your data set with temperature greater than 70 and also for the month of May only, then you use an and, or you could use or. If you remember the set operations back in high school, it's and or. So or in R is written by this symbol, which will be right above your enter sign. That's the backslash. It's the backslash, but you have to use a shift. So it's this piping like line. So if it is or, then it means it will give you all the rows which satisfy this or this. So or really doesn't mean much in this case. So it's and, which means it will satisfy both these conditions, and the rows which satisfy both these conditions will only be displayed. So yeah. So I use greater than, you could use equal to 5 too. So then you will get only the temperature that is greater than 70 for the month of May. All right, so the next function is called mutate. So mutate is used when you want to do some operations on the existing columns. If you want to do some arithmetic operations or calculations on your existing columns and create a new column and add it to the existing data set, then you use mutate. So what we are using mutate here for is you use mutate, give it the data set, and here we are creating the new column named temp inc, and we are performing some calculations on it. We are saying use the temp column and convert it to Celsius. Usually the temperature in the US and also in this data set is a Fahrenheit, and you'll have to convert it into Celsius, and then we are trying to add that column to this data set over here. So we are using the calculation to convert temperature into Celsius. So temp, you subtract 32 and then you multiply it with this 5 by 9. So this is the new column that's been added to the existing air quality data set, and you have this temperature in Celsius. So if you want to mutate, is used when you want to perform calculations and add a new column to the existing data sets. And the next function is called summarize. So summarize, what it does is, this is something more we are trying to get, if you have known any of the database languages like SQL, SQL or PL SQL. So most of them have something like count by, count, group by, and many things like that. So starting from this slide, we will be looking at those kind of operations. So this is summarize slide is just to use whatever function you have on the inside the summarize function. You use that function to your data set. So you have many ways of doing this, right? So this is not something unique to this package. You have many ways of getting the mean of one particular column or the data set. So again, this particular function can do more than just apply a function, which we will see in this slide. So in the previous slide, we are just getting the mean of the temperature within the air quality data set, and then you are saying remove all the values which are not available. So we are getting the mean here, but it's more useful for things like this. If you want to use grouping by certain months. So here what we are doing is within the air quality data set, we are grouping them by month first and then applying this mean. So what we are attempting to do here is get the average temperature for each month that is of the data available within air quality data set. So you'll have to first group your data by month and then apply mean to each month. So summarize is usually much useful in situations like these, where you use the function group, where you group by certain columns and then use a certain function. So here group by again is a new function. So you use group underscore by, and you group this data set by month, and to those individual grouped smaller data sets by month, you apply this mean. So you see the result over here. For each month, you're getting the average temperature for that month. So the next is sampling. If you want to randomly select a few rows from a table, the sample function is used. Sample function is usually the typical sample, just the sample without any extensions, is available in the normal R, not just it's not linked to this package, but there are two other functions, which is sample underscore n and sample underscore frac, which are specific to these to this package. So sample underscore n is when you want to randomly pick a few lines from the data set. So if you have the air quality data set and you give it the size of 10, what it's going to do, it's going to pick 10 rows at random from this data set, from the air quality data set. And as opposed to if you want to pick a fraction of your data set, usually we do fractions because if you want to train a model on say 10% of your data or 20% of your data, or similar like that, or if you want to divide your data set into half and half, then you say 50%, pick 50% at random and leave the rest. So give it sample underscore frac, and which stands for fraction of the data set. You give it the data set name and you give it the size. 0.1 is 10% of your data. So how many ever rows it has, it will pick 10% of that. So this data set has 153 rows. So 10% of that will be 15 rows. So this line is going to pick 15 rows from your data. So the other function is count. Count is just a frequency table. So it's just going to tally the number of observations in that group, and it's going to give you a number based on how many observations there are. So if you say count air quality, and if you give it what to count, and here you're giving it the month, so it's going to give you the number of observations observed for the number of months. So within the air quality data set, there is only data for these 5 months. So it's going to give those 5 months and the number of observations there are for that month in that data set over here as n. And I think this is the last one. So the last function is the arrange function. So this is just to display your data in a way that you like. So mostly this is within the air quality data set, it's arranged by the month and then the day. But if you want to reverse that order, if you want to display it in a ascending, descending order, whatever you want, whichever order you want, you'll have to use arrange. So arrange, give it the data set name, and then use this function called descending, that stands for descending DESC, and descending month, and then the day. So if you don't give it anything, the default is ascending, so it will start from low to high. But if you want to specify the order in the reverse order, so you'll have to specify the descending. So descending order, so it's, since it has from month 5 to 9, because it's descending, it goes from month 9 to 5. So month, and then the day will still be an ascending because we didn't use a descending function for the day over here. So that pretty much marks the end of this class. Any questions?